Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahilladzi hadana lihada wa ma kunna nahtadiya laula an hadana Allah. Asyhadu an la ilaha illallah wahdahu la syarika la wa asyhadu anna Muhammadan abduhu wa rasuluh. Praise be to Allah, the creator and sustainer of the world. Okay.
Okay, we will present the poster about application of linear differential equation system in water discharge solution on pipe by Azizrisky and M. Abstract. One of the problems in daily life that are quite complicated to solve is the fluid flow system or water in a multi-level vessel. In study model, a system linear differential equation has been developed which describes the flow of water from a water installation system with a multi-level vessel and compare the results of the numerical simulation with the experimental resolution. The SPTL model was built by involving direct field observation to determine the constant C1, C2, and C3. The model that has been built by simulate numerically using the Euler method with first scenario or constant value. The results show that the volume of tank A and B and the rate of change of their water volume have been successfully described by the SPTL model that has been built with results close to the experimental results, namely the C1 value of 0.01356 and C2 of 1001091 with RMSA value 0.2599. Introduction. One of the problems in the everyday life is quite complicated is fluid flow system water on a multi-level vessel. In this case, the volume of water in tanks A and B will continue to change per unit time due to input water in A and water output out. In the case of study, the general model of the SPTL illustrated by figure 1 can be seen the equation 1, 2, 3, where Q is the water flow rate, VAS is the volume of water in tank A, Vp is the volume of water in tank B, and T is time, C1 and C2 are constant. Material. The equipment used in this research is a water installation system consisting of 3 tanks, 1 conventional water pump, and 1 camera record, while the material used in as the fluid object used. Methodology. A. Research procedure. The pipe installation unit consists of 3 water tanks, A, B, and C, 4 valves connected to the pipe installation, and 1 configural water pump. This test begins by filling tank C to the brim. Then the pump is turned on. The water discharge entering tank A is measuring to determine a value of C or C3. C3 measuring by letting the pump fill tank A to central volume with valve to close. The opening of valve 1 is opened halfway so the tank water in tank C does run out quickly. The value of C3 calculated using equation 4. C3 is determined by calculating the volume change per 3 seconds until the volume of tank A reaches 20 liters. Furthermore, To find the value of the constant C1 and C2 is then necessary to observe the rate of change of the volume of water in tank A and in tank B. Observation begins by opening valve 2 and valve 3 fully so that the water flows. In this condition, the water in tank A has a volume of 20 liters. The rates were obtained from the observation of change in volume within 190 seconds or 3 minutes in tanks A and B at the valve condition 1, 2, 3 open as described above. The rates are calculating using question 5 and 6 respectively. Furthermore, to calculate the value of the constant C1 and C2 is equation 7 and 8. B. Research analysis. Euler method is also called by the first order method because the search in the equality one only takes up the first order. Euler's method also uses the help of the Taylor series. Numerical calculations were carried out to determine the volume in length A and B using several scenarios of the value of C1 and C2 in order to obtain the model that is close to the truth.
Okay, and then result A, value of constant C3 pump discharge. The value of C3 is constant because the pump flows water discharge constantly with the condition that the rotational speed is constant, so that the effective value of C3 is obtained, which is 0.175 liter per second. And B, value of constant C1 and C2. Okay, in this study, the volume change in tank A and B were observed every 10 seconds. From the result of table 2, it can be seen that the effective value for C1 is 0.01312, while the value for C2 is 0.010, and blah blah blah. And this the table you can look. And then point C, comparison of numerical and experimental method. Based on the table 4, the model that products the smallest RMSE value is scenario I with a value of 0.2599. So that scenario I is the scenario 1 is the best model which produces an error below 2%. Thus, the result of the numerical simulation in this research case are an ideal description of the change in the volume of water in tanks A and B per unit time. But in reality, the experimental results of a curve that that is not smooth due to factors that affect the acquisition of the measurement result, starting from the smallest scale of the water volume measuring instrument. Okay, sorry. Lack of precision in measuring time and observing the volume of water, especially those carried out manually by A. However, the experimental and simulation results seem to have almost the same pattern so that the SPDL model has been able to describe the condition of the rate of change of water volume in tank A and B continuously from the simulation result of four scenarios. The most suitable model in description the case of the water flow system in this multi-level tank is scenario 1 with C1 values 0.01323 and C2 0.01091. Okay, and in the last conclusion in this for from this topic A conclusion, it can be concluded that be condition of the water volume of tank A and B as well as the rate of change in the volume of water at time unit show almost the same trend. The best results are obtained in scenario 1 with the value of C1 and C2 speaking respectively 0 dot 0.01323 and 0.01091, where the RMSE value in this scenario is the smallest, which is 0.2599. The inaccuracy of the experimental result occurred because the measurements were carried out according to conditions in the field where the water volume measuring instrument has a low level of accuracy and the observation were carried out manually using the eyes. The result of the numerical simulation of the Euler method using SPDL has been able to describe the ideal condition of a multi-level water flow system so that the condition of the water volume and the rate of change in volume can be predicted close to the actual condition. Okay, and the last B suggestion experimental measurement need to be carried out using more precise measuring instrument and using a data logger that is able to record data simulation continuously and avoid observational errors. This is our poster about application of linear differential equation system discard simulation in water, discard simulation on PIP. This is from our. Thanks for attention. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.